Hello, hello. Hi guys. I hope all of you are doing well. So I welcome you all to yet another video in this Databricks playlist. And in this particular playlist, we are going to build an ETL pipeline using the CDC, that is change data capture. And where we are going to this particular build this pipeline, we are going to build this particular pipeline using the Lakeflow Spark Declarative Pipeline engine. So in the previous video itself, we have discussed about the components of Lakeflow SDP. So in this video, we are going to see them implement practically. So I hope you guys will learn a lot in this particular video. So in this particular playlist, we have talked about Spark from the very basics till the advanced concept of Spark, like how we can rename a column, how we can add a new column, how we can do merge operations, how we can do join operations, group by operations, as well as how we can handle null values, and we can read JSON file formats. And read the knowledge of reading those JSON file formats is going to come into picture in this particular video also. So if you're someone who is looking to learn Spark from the scratch, or someone who just wants to brush up the advanced concept, the playlist can be helpful for any one of you. So with that said, let's get started with this video and let's get straight into the system. So the agenda for today will be to build an ETL pipeline where we will be using the change data capture. So learn how to create and deploy an ETL extract transform node pipeline with CDC, that is change data capture, using Lakeflow Spark declarative pipelines for data orchestration and autoloader. Okay, so till now we have covered all these concepts, whether it is ETL or it is CDC or understanding the components of Lakeflow SDP. We have already covered all these concepts in the playlist till now. But now what we will be doing is that we will be integrating all these things together to create one single pipeline, taking advantages of all the properties, be it the advantage of the CDC, be it the advantage of Lakeflow SDP, or obviously ultimately the job of we data engineers is to nothing but to create a good ETL pipeline which is efficient, as well as it can handle all the edge cases that comes with handling the varieties of the data as well as the volume of the data that we handle. So an ETL pipeline implements the steps to read data from sources, transform that data based on requirements such as data quality checks and record deduplication, and write the data to a target system such as a data warehouse or a data lake. Okay, so here what we will do is that we will read data from a source. We will have a source system, then we will transform the data based on requirements, such as the requirements will be data quality and record deduplication, and then we will write the transformed data to a target system. So it can be a data warehouse or it can be a data lake. Okay, so in this tutorial you will see data from a customer table in MySQL database, to extract the changes from the transactional database using Debezium or another tool, to save them to cloud object storage, S3 or ADLS or GCS. Okay, so here what we will be doing is that we will extract the changes from the MySQL. So MySQL is basically a transactional database itself. So we will extract the changes from MySQL using Debezium. So Debezium is basically a tool which captures CDC. So if you go here and if I open the Debezium page, right? So you can see stream changes from your database. Debezium is an open source distributed platform for change data capture. Start it up, point it to your databases, and your apps can start responding to all the inserts, updates, and deletes that other apps commit to your database. Okay, Debezium is durable and fast, so your apps can respond quickly and never miss an event, even when things go wrong. Okay, so basically it's a CDC tool that can capture the change in your data, and it will give us the CDC feed, that is the change data capture feed. Okay, so we have to start it up, like we have to set up the Debian because it's an open source, so I don't think we have any kind of no, we don't have any kind of hosted platform for Debian. Okay, so we will have to set it up, like we will have to self host it. So if you want how you can do the setup and all those stuff, so you will have to go to GitHub of Debian. If you will scroll at the bottom, for sure we will have some kind of setup, right? Links below for installation, Docker here. So here you can we can use Docker, right? And how to set up and configure Docker environment for starting up the Debian, you can see it's given. Building up the code, we can use MVN, okay, Maven basically, to set up all these things, right? And obviously the official documentation will be there to set it up, right? So you guys can set it up. Obviously it's not our job, I am just saying it. Okay, set it up, point to the database, okay, point to the database that we want to capture the changes from. Then the apps can respond to all the inserts, updates and deletes, and whatever commit is made to the databases. Okay, so it will start capturing the inserts, updates or deletes, whatever commit or whatever things is changing in the databases. Okay, it is durable and fast, and all these stuffs are cool. Okay, so all in all, Debian is basically a CDC tool. Okay, so in this tutorial, you skip setting up the external CDC system and instead generate fake data to simplify the tutorial. Okay, so what in this tutorial, what we will be doing is that we will skip setting up the external CDC system, right? It means that we will not be using this Debian part to basically to capture the CDC, right? But we can use Debian to capture the CDC. Here what we will be doing is that we will generate a fake data. Okay, we will generate a fake data, something like which something like that Debian will give us while capturing the CDC. Okay, use autoloader to incrementally load message from cloud object storage. Store the raw messages in customers underscore CDC table. Autoloader infers the schema and handles schema evolution. So we will also use autoloader so that it incrementally stores the message in the cloud storage. Okay, whatever cloud storage we will be using, or whatever basically storage we will be using, autoloader will do a incremental load to the storage, right? And it will store the raw message in customers underscore CDC table. Okay, so we will be having a table named customer underscore CDC. It will be storing all the messages there. So why we are saying messages here? Because we are aware about that autoloaders work on a streaming data. So we usually say the data that we are getting in the streams as messages. Okay, so here raw messages means the raw data or the raw rows that we will be getting. It will be stored in the customer underscore CDC table. Autoloader infers the schema and handles schema evolution. So autoloader will infer the schema, means it will basically check the schema, as well as it will also handle the schema evolution if any kind of schema evolution is made in the data. Okay, then what we will do, we will create the customer underscore CDC table to check data quality using expectations. Okay, for example, the ID should never be null because it's used to run absurd operations. Okay, so here what we will be doing is that we will do a data quality check on the customer underscore CDC table, and we will create a new table as customer CDC underscore clean. And what kind of data quality checks we will be doing? That we will check that the ID column should never be null in this particular case, because using ID itself we will be running the absurd operation. Absurd operation means when we will be using SCD, that is slowly changing dimension, there the absurd operation happens, right? So we'll be using the ID column to do it. Then perform auto CDC into on the cleaned CDC data to observe changes to final customer table. Okay. Then we will also use auto CDC, right, to the cleaned data, that is to this particular table, customer CDC underscore clean table, to observe changes to a final table. Basically, so if I talk about the Medallion architecture, right? Okay, let me open my Epic Pen just once. So if I talk about the Medallion architecture, so this table will act as the bronze layer. Okay, this table will act as a silver layer, and this customer table now will become the gold layer table that we usually have. So these are the three layers that we have in the Medallion architecture, which Databricks usually ask us to follow, right? So we will perform an auto CDC on the cleaned CDC data, that is this data, to observe changes to the final customer table. Then show how a pipeline can create a type 2 slowly changing dimension SCD2 table to track all changes. Okay, so in auto CDC we will be using SCD type 2. The goal is to ingest the raw data in near real time and build a table for your analysis team while ensuring data quality. Okay, so the goal of this particular I would say ETL pipeline will be that we ingest near real time raw data and ultimately build a table that will be customers that the analytics team can use, and we will also ensure the data quality that in customers table or in the gold layer the data quality is maintained. Okay, so here you can also read that this tutorial uses the Medallion Lakehouse architecture, which we have already talked about, where it ingests raw data through the bronze layer, cleans and validates the data with the silver layer, and applies dimensional modeling and aggregation using the gold layer. So if you want to know more about the Medallion architecture, you can go on to this particular link and understand about the Medallion architecture. Cool. So this is how my architecture will look like, or I would say my whole pipeline would look like. That I will ingest raw CDC files that will be in a JSON format. Okay, so autoloader will incrementally load the new data to our bronze layer table, that is customers CDC underscore bronze, right? Then we will clean the data, clean CDC data, and make sure data is correct. Whatever data quality check we want to do here in this step, which is defined in this step, we will do it, and we will store the data in customers underscore CDC underscore clean. Then we will use auto CDC, so automatically merge and materialize the customer table. So using auto CDC, we will create first of all a customers table, and then we will using CDC type 2, we will create a SCD type 2, slowly changing dimension type 2. We will be creating basically a customers history table, and then on top of this customers history table we will create a materialized view, and the ultimate table that we will be getting will be customers underscore history underscore aggregated. Okay, so this will be my whole pipeline that we will be following in this particular tutorial, or I would say in this particular video. So for more information about pipeline, autoloader and CDC, you can visit to these links, and we have already in very great detail we have talked about these concepts in the playlist, right? Then talking about the requirements. So to complete this tutorial, you must meet the following requirements. First of all, be logged in the Databricks workspace. Obviously, without logging in into the Databricks workspace, we will not be able to do anything. Then have Unity catalog enabled in your workspace. So to maintain the data governance, we will require Unity catalog in the workspace. So we should have Unity catalog enabled in the workspace. Then have serverless compute enabled to your account. Serverless Lakeflow Spark declarative pipeline is not available in all workspace regions. Okay. See features with limited region availability for uh, available regions. If serverless compute is not enabled in your account, the steps should work in the default compute for your workspace. Okay. So these will be the locations where Lakeflow SDP is enabled. It's not available in all the locations. So if I talk about our location, so it's US East 2. So this is for the security features. We will have to look for serverless availability, right? Serverless availability, and we have to look for serverless workspace, serverless compute, right? So you can see serverless workspace and serverless compute. So for US East 2, US East 2, okay. So we have the access to all the regions. Both of the services, I would say, in US East 2, right? We have the access of serverless compute also, and we also have the access of serverless space as well as managed connector for a Lakeflow connector also we have in US East 2. Basically all the services we have, right? So we need not worry about. You can see here that in US West 1, you don't have the service for Mosaic AI model training. So for different regions, we don't have different services that may not be available. So you can check here if you want to know that if that particular service is available in the region where your workspace is deployed, if it is available or not. Okay. If serverless compute is not enabled in your account, the step should work in the default compute of your workspace. Okay. So even if serverless compute is not there, the default compute that you guys will be having, it will work in that also. You need not worry about, like, it's not necessary to have just the serverless compute. Your permission, have permission to create a compute resource or access a compute resource. Okay, because we will need computation in this particular video. Have permission to create new schema in a catalog. The required permissions are all privileges or use catalog and create schema. So if you are working in an organization, right, in that particular case, the account admin will not give you all the privileges for creating a new schema, right? So in that particular case, you will have to ask for the privilege that, okay, you can give me the privilege of use schema, use catalog and create schema, right? Because usually, like even in the Databricks documentation, we have read that Databricks usually works on the least permission model, right? That you should only give those privileges or those permissions that is least required to do a job. You don't give or grant any kind of extra permissions or extra privileges to any of the users, right? So even all privileges means that you will be basically you can basically create a schema, delete a schema, modify a schema. So I don't think that until unless you are at a very top level, right, top authority, they will not be giving you all the privileges. So you have to mention that, okay, for this particular use case, I need these privileges to do the job done. I'm not only talking about this video or this pipeline. I'm talking about as a general, as a whole, that in your I would say in your what we call this corporate journey, right? You will be requiring all these things, and you will have to let the admin know that, okay, these are the permissions that you require to get the job done. Okay. Then have permission to create a new volume in an existing schema. So the required permissions are all privileges or use schema and create volume. Okay, so these will be the permissions that will be required. But here we are the whole sole owner of the account, right? We are the people who are having the account. So I don't think that any of the permissions we will not be having. We are the root user basically of the account, right? Then change data capture in an ETL pipeline. So change data capture is the process that captures changes in records made to a transactional database. For example, MySQL or PostgreSQL or a data warehouse. So we are already aware about the fact that if any changes are made to the records in the transactional database, right, CDC can capture those changes and store it in a separate table along with some metadata also, right? And it can also work with data warehouses. CDC captures operations like data deletes, appends, and updates. So even if we delete any data, it will capture it. If we append any data, it will capture it. As well as if we update any row, it will also capture those changes. Typically as a stream to rematerialize tables in external system. Okay. So typically the CDC will be a stream, right? We are in the CDC video also we have seen that the CDC feed usually acts as a stream. It does not act usually as a bulk data, right? Or a batch data, I would say, not bulk data. It does not act as a batch data. CDC enables incremental loading with eliminating the need for bulk load updates. Okay. Now to simplify this tutorial, skip setting up an external CDC system. Okay, we will not set up any kind of external CDC system like Debian. Okay, assume it's running and serving CDC data as a JSON file in cloud object storage such as S3 ADLS or GCS. This tutorial uses the Faker library to generate the data used in the tutorial. So in this particular video, we will not set up any kind of external CDC system such as Debian or any other system. What we will do is we will just use the JSON file that we will generate from a library called Faker, right? And we will be we will generate that JSON file in such a way that it acts as the CDC data that usually systems like Debian will give us. Okay. Now capturing CDC. So a variety of CDC tools are available. One of the leading open source solution is Debian, but other implementations that simplify data sources exist, such as Fivetran, Qlik, Replicate, StreamSets, Talent, Oracle Golden Gate, and AWDMS, right? So Fivetran, I guess, is even more popular than I would say Debian. Okay, so Fivetran is basically, I would say, a hosted version of Debian. Okay, so it can give us connectors. You can see here, like even in the solutions, no, not solutions, in product, right? So you can capture transformations. It will give us the security, the governance, accessibility, RETL. There is something RETL, right? Activate your data back into your data applications. Not very sure about what exactly RETL is. Then hybrid deployment, all these things. So basically, Fivetran is an organization. We will have to pay for it, right? And so you can see there are n number of connectors. More than 700 connectors are there, and most of the large companies like Volkswagen, Louis Vuitton, and OpenAI, Salesforce, and all these companies, Spotify, are using this particular platform. So this is also one of the most well-known platform for capturing the CDC. Okay, so let's move back. So in this tutorial, you use CDC data from external system like Debian or DMS. Debian captures every changed row. It typically sends the history of data changes to Kafka topics and saves them as files. Okay, so Debian will usually send, because we are again, if I'm repeating myself, that the CDC feed will be a kind of streaming data, and we will not be directly storing the streaming data into a database. We will be storing it somewhere in a system like Kafka, maybe Apache Pulsar, right? AWS SQS or systems like that, right? So it will be sending those particular changes to the Kafka topics, and it will save them as files. Then you must ingest the CDC information from the customers table in JSON format, check that it is correct, and then materialize the customer table in the lakehouse. So we will do the same thing, that we will from the customers table, which will be in JSON format, we will ingest that particular table in the bronze layer, right? And then what we will do is we will do the data validation, and then we will, after doing the data validation and doing the checks, we will dump that particular data into the silver layer, and then from there we will materialize the customer table into a lakehouse. So this will be my whole pipeline as already discussed here. Right now, CDC input from Debezium. So for each change, you receive a JSON file containing all the feeds of rows being updated. Okay, so whatever change is made, we will receive a JSON file containing all the fields. All the fields means all the columns. Fields here means columns. So we will receive all the columns or all the fields of that particular row that has been updated. Okay, so here we will be having fields or columns like ID, first name, last name, email, and address. Okay, the message also includes additional metadata. So the first column will be operation. So an operation code, typically it will be delete, append, or update. Okay, then we will have a column as operation date. So the date and timestamp for the record for each operation action. So whatever operation is performed, right, it will capture the timestamp of date and timestamp, means it will also have the date and the time when the operation was performed for that particular row. Okay, so tools like Debezium can produce more advanced output such as row value before the change, but this tutorial omits them for simplicity. Okay, so it can also provide some more additional and more advanced kind of metadata, I would say, right? But for this particular video, for the simplicity of this particular video, we have left those things. Cool. Now let's get started and let's begin to create the pipeline. Okay, so first step is to create a pipeline. So what we will do is we will start following each and everything one by one. So first of all, we will create a new pipeline to query your CDC data source and generate tables in your workspace. Okay, so first of all, let me open my Databricks workspace. So Databricks, let me open my Databricks workspace. Please sign in, continue with Gmail. It's JSE 8B. Okay. Cool. Now what we have to do is, first of all, we have to create a pipeline. So to create a new pipeline, like go in your workspace, click on new on the top left corner. Okay, so click on new on the top left corner. Then we have to create on ETL pipeline, right? Click on ETL pipeline, change the title of the pipeline to this. So okay, let me just copy, or your prefer name. So I will copy this name here itself. So I will go to ETL pipeline, and here I will paste the name. Okay, and then under the title, choose a catalog and schema for which you have the permissions. Okay, this catalog and schema are used by default. Okay, so here you can see we have the option to choose the catalog and to choose the schema. So if we want to use the default schema, we can choose here, or any other schema if we want, we can just click on this, or we can also create a new schema if we want to. Okay, So this catalog and schema are used by default. If you don't simply, if you don't, sorry, if you don't specify a catalog or a schema in your code. So if you are not specifying any schema and any catalog in the code, means we only give the table name, right? We will not, if we don't specify any catalog or schema. So this will be the default catalog and schema that will be used in my case, right? Right now I have chosen this workspace catalog and default schema by default, right? So your code can write to any other catalog or schema by specifying the full path. So let's suppose if I want to store the output in, let's say, test db. So there I will have to specify that thing in my code, that let's say x table I have to store in my test db. So I will have to give the full path, that workspace dot test db dot x. We have to write the data in this particular table. So this is how it will work. If we don't, if we only put table x, then it will save or create the table x in workspace dot default. Okay. This tutorial uses the defaults that you specify here. Okay. So here we will be using the default path that we have specified. So here it will be always workspace dot default. From advanced option, select start with empty file. Okay. So let me go back. Let me choose empty file. So here this should be my folder path, and I'm going ahead with Python. If you want, you can also choose your starting language as SQL, but I would go ahead with Python only, and I can click on select. So you can choose Python or SQL for the language of your file based on the language you want for the tutorial. Then click select to create the pipeline with these settings and open the Lakeflow pipelines editor. So it will open a pipeline editor for me. Okay. So, okay, cool. Now, now what we will do is we will create the sample data to import in this tutorial. Okay. So this step is not needed if you are importing your own data from an existing source. So if we already have some kind of data that we want to import into our pipeline, CDC pipeline, then we don't require this step. But currently we don't have any kind of external source or external data that we will be ingesting. So we will have to create a fake data that we will be using. So for this tutorial, generate fake data as an example for the tutorial, right? So we have even in the playlist, we have used Nemesis to generate fake data, right? For our use case. Here we will be using the faker library. So totally depends on you. You can use faker, you can use Nemesis or any other library if you want to. There are multiple libraries to do it. Then create a notebook to run Python data generation script. This code only needs to run once to generate the sample data. Also create it within the pipeline's explorations folder, which is not a part of the pipeline run update. Okay. So we will have to create this particular, or I would say we will have to run this particular code in the exploration folder. So what will happen if we are running it or creating it in the exploration folder will be that we will have to manually run the code let's suppose anytime we want to run it. Okay, it will not be, so here if I click on this run pipeline, let's suppose I have written some code here, and if I click on this run pipeline, and if I am writing that code in the transformation folder, right? So it will run that code every time. It will generate the data every time I will run my pipeline. But if I am creating it in the exploration folder, it will not run. It will not run as the pipeline update. Okay. So this code uses Faker to generate the sample CDC data. Faker is available to install automatically. So tutorial uses pip install Faker. You can also set the dependency of the Faker on notebook. Okay, so if we want, so from here, comments, no, not comments, settings. Yeah, from configuration, we can also add if we want to, no, not configuration, sorry, advanced settings. Jason. Schedule settings, it was somewhere right here, version history, assistant, comments, pipeline graph. I guess it will be available once we run the pipeline. Add parameter, right? I guess this is the one. Okay, I will have a look, right? Till then, let's use the pip to install the faker. Okay, we can also do it, or if you want to read more, you can also go on this add dependencies to notebook, right? You will see right here. Okay, we will have to create a folder, helper utils. Then in helper, we can define the utilities. Got it. I guess from UI also we were able to create configure environment for job task, environment and libraries in the drop down menu. It should be there. That's exactly what I was searching for. Commands, version history, full refresh with different setting. No. Not able to find it right now. Okay, no worries, right? Let's move forward. So from like we can obviously always use the pip install to install any library, not only faker. If we want to install any library, we can go ahead with pip install. Then from within the Lakeflow pipelines editor in the asset browser, sorry, from the Lakeflow pipeline editor in the asset browser sidebar, click to the left of the editor, click add and then choose exploration. Okay, so we will click on this add and we will choose exploration. Okay, then give it a name such as data setup. Okay, so let control C and we will do data setup itself. Let's say I'm using an underscore and I will use the language as Python and I will click on create. Okay, click create. This creates a new notebook. Enter the following code in the first cell. You must change the definition of catalog and schema to match the default catalog and schema of your of that you selected in the previous procedure. Okay, so I will just copy this. I will come back here. Okay, so spark.sql use catalog workspace. This is fine. So what I will do, let me just delete this cell. I don't require this. I will click on code and I will paste the code here. Okay, and after doing this, what I will do is I will change the catalog name as workspace and I will change my schema name to default. Rest of the things should remain the same. Okay, so what we are now doing is, first of all, we will do a pip install faker. Okay, that is the library that we will use to create the fake data. Then we have defined our catalog. We have defined the schema, DB name and DB. So all these three variables are having the same value as default. So somewhere we will be using DB name, somewhere we will be using DB and somewhere we will be using schema. Everything like any of these three we use, the value will get as default itself. Okay, now from spark.sql, right, we are using this catalog. We will use this schema and spark.sql create volume if not exists. Okay, catalog.dbname dot raw underscore data. So it will, in my default uh, in my default schema, basically it will create a volume named as raw underscore data. So currently if I go to my catalog, if I show you guys, catalog in workspace and in default schema, right? If I go into, so you can see we are having 28 tables and 2 volumes. If I go into volumes, we are having db utils and life underscore part volumes, and here it will create one more volume as raw underscore data. Then the volume folder will be volumes slash catalog slash db raw underscore data. Okay. Then try dbutils.fs.ls volume folder slash customers. Okay. So volume folder means the volume raw underscore data. Okay. So what it will do is it will try to first of all see that if any data is available in this customers folder or not. Ls means list. If you have watched the dbutils videos that I have talked about, in the dbutils videos, I have told that fs does what? It lists the whatever content is present in that particular directory, right? It will list all the materials basically, or all the content, you can say. Whatever, let's suppose if you are having any folder, any file or anything, it will give me a list of contents that are present in that particular folder or in that particular directory. So here it will give me volume slash catalog slash db raw underscore data slash customers directory if it is created, and if it has anything, it will give me the list of it. Else what it will do, it will print that folder does not exist, generating the data under this particular volume folder, that will be raw underscore data. Then for generating data, what it will do, from PySpark.sql we will import functions as f. Then we will import faker. From collections we will import ordered dict. Then we will import uuid. We will create an object of the faker, and then we will import random. Okay. Then faker dot first name. Okay, fake underscore first name, it will be equals to function dot udf. Okay, we will create a udf, and we have done what? Fake dot first name. So it will basically generate the first names. Then last names. So function dot udf, it will generate last name. For email, so udf fake dot sky company underscore email, so it will generate me the fake emails. Then fake date, so f dot udf lambda fake dot date time this month, and the time will be month, date, year, hour, hour, minutes and seconds. Okay, so it will generate the date from this month, right? That like it will not exceed the dates from this particular month, whatever we are having. So let's suppose we are having December, so it will not exceed the date of from December only. Okay, it will create from the previous months of December only. Okay, and it will create in the format of month, day and year, hour, minute and second. Then it will create fake addresses. Now it will create operations column. Okay, so it will create an ordered dict where 50%. So here you can see there are multiple operations, like not multiple, there are basically 3 operations: append, delete and update, right? So we are seeing this and we are seeing none, and these numbers indicate that it will create 50% of the data as append, 10% of the operations will be delete, right? 30% of the operations will be update, and 0.01 means for if I talk about percentage, so it will be 0.1. Okay, 0.1% will be none. So in operations column, we will also see some none values also. Okay, apart from these values, that is append, delete and update, and the weightage of it will be 50%, 10% and 30%. Then operation. Okay, so udf lambda dot fake, and it will create, and the length will be 1, and it will be picking up the 0th index of that particular function. Okay. And then what it will be doing is it will create a fake ID, and this is how it will create a fake ID. Like more than 98% will be having some IDs, and some percent will be having none values also. Then df will be spark dot range. Okay, from 0 to it's 100 and lakh, right? So from 0 to 1 lakh, and we will repartition the data into 100. Okay, so basically it will create multiple chunks of data. Then we will add the ID column, the first name column, last name, email, address, operation, operation date, and ultimately what we will do is df underscore customers. We have appended everything, right? And df underscore customers dot repartition to 100, right? Dot write format will be JSON, mode will be overwrite, and it will save the data to volume folder slash customers. So inside this raw data, basically raw data volume, it will create a folder named as customers, and inside that customer, this whole part file of 100 partitions will be created. Okay, and now if I just press shift and enter, so it will start running the code. So obviously it will take a few minutes to do it. Okay, so now the code has run successfully. Okay, if I go back here and if I refresh the page, so now you are able to see a new volume that has been created as raw underscore data. And if I go inside this raw underscore data, we will have another directory that has been created, that is customers. And if I go into this customers directory, we can see that there are hundreds of part files that has been created, right? Part file 099, and it's 099 because it starts from 0. So 100 part files has been created, right? Each and every part file will be having how much data? 1 lakh divided by 100. So every part file will be having around 1000 rows in them. 1000, yeah, 1000 rows in them. Okay, now if we want to look at what data do we have inside this uh, customers volume, so how we can do it? We will do it something like this. So I will copy this, I will come back here, I will paste the code, and now catalog I will keep as workspace. Default, that's it. And now if I run the code, okay, so this is how my raw data looks like. We have address, okay, we have address, we have email, right? If I just push it down, right? So we have address, we have email, we have first name, ID, last name, operation, and operation date, right? And here, if you talk about the operation, so you can see we have update, we have append, we also have null, and we should have delete also. Delete, right? We also have some delete. Why you can see delete less? Because only 10% of the operations are given as delete, right? You can see there are multiple deletes. Even null values, a very less null values will be having, right? Here one null is there, right? Here one null is there, right? So only a few null values you will be able to see. Cool. So this is the raw data that we have created for our, and this raw data is basically what? This is the CDC stream that we will be getting from tools like Debezium, right? This is not even the data, the transform data or the bronze layer data. This is the CDC stream that we will be getting. Okay. Now what we will do is we will incrementally ingest the data to the autoloader. So the next step is to ingest the raw data from the faked cloud storage to bronze layer. Okay, so now we will ingest the data from the faked cloud storage. So we are faking this particular thing as our cloud storage, right? Or the CDC stream that we are getting from tools like Debezium and all, right? So to the bronze layer. Now this can be challenging for multiple reasons. So the first challenge can be operate at scale, potentially ingesting millions of small files, right? So here we have only hundreds of small files. When we are dealing with the industry level data, we can have millions of files in the volume, right? So we can have to operate at scale, right? Then infer schema and the JSON type. So we have to also infer the schema, means we also have to check the schema, as well as here we are dealing with the JSON file format, right? So basically a semi-structured kind of file format, right? The JSON has. So it is not very difficult to handle the semi-structured data or JSON file, but comparatively compared to the structured files like CSV, TSV and all, it's a bit difficult to manage comparatively, but it's not that even difficult. Okay. Handle bad records with incorrect JSON schema, right? So if the schema is incorrect, so we will have to handle the bad records. Take care of schema evolution. So let's suppose if new column gets added, if any kind of column changes there, right? If any columns get deleted and all those stuffs. So we will also have to keep in mind the schema evolution. Now, if we are going to check all these things manually, right, using Apache Apache Lakeflow declarative, sorry, Apache Spark declarative pipeline, okay, Apache SDP, if we will be using, in that particular case, we will have to write each and every line of code for handling all these things. Okay, the logic and everything we will have to write by own, because that is a procedural way, right? We will have to go ahead with the procedural method if we are going with the Apache Spark declarative pipeline. But here, because we are using the Lakeflow declarative pipeline, in this particular case, we will have to only define the agenda, right? Then talking about autoloaders. So autoloaders simplifies this ingestion, including the schema inference and the schema evolution, while scaling to millions of incoming files, right? So whatever issues we are having, that even if we have to operate on millions of files, we have to do the infer schema check, we have to handle the schema evolution, each and everything will be handled by the autoloader itself. Autoloader is available in Python using cloud files, and in SQL using the select star from stream read files, and can be used with a variety of formats such as JSON, CSV, Avro, etc. Okay. Now defining the table as streaming table guarantees that you only consume the incoming record. Okay. So we will define the table as a streaming table. Why? Because in that particular case, we will only consume the incoming record. We will not consume all the record as a batch or as a bulk. Okay. If you do not define it as a streaming table, it scans and ingests all the available data, right? We are already aware about this, right? That if you are describing it as a normal delta table, it will scan and it will ingest all the data that is available, right? So to ingest the incoming CDC using autoloader, copy and paste the following code into the code file that was created in your pipeline called mytransformation.py. You can use Python or SQL based on the language you choose while creating the pipeline. Be sure to replace catalog and schema with the ones that you have set up by default for the pipeline. So we can go ahead with either the Python code, or if you want to go ahead with SQL, so you can also use SQL code to do the same thing. So because we have chosen Python, right, as the base programming language, so we will go ahead with Python. In transformations.py file, I will come here and I will just paste this line of code. And before running it, let's understand what is this code all about. So from PySpark, import pipelines as a DP. Okay. Then from SQL.functions, import star. Means all the everything from the functions module. Okay. Then we'll be giving the path. So path is volumes / workspace / default / raw underscore data / customers. So this is the path of our volume that we are having, right? The same path that we have given here. Now what we will do, dp dot create streaming table. Okay. Now the table name will be customers underscore CDC underscore bronze. Okay. And the comment we will be adding to the table is this, that new customer data incrementally ingested from object cloud stored landing zone and all these things, right? So whatever comment, this is not necessary, we can even remove it, right? Now we are creating a decorator as dp dot append flow. Target, we are giving this table, right? This is the target table. This is the name of the function basically, right? And the function that we are defining is apache.readStream, right? Format will be cloud files, as we have already talked about it here, right? Autoloader is available using cloud files. So because we are using autoloader, so format will be cloud files dot option cloud files dot format, that is JSON. We are already aware about that. The file type is JSON. And cloud files dot infer column types is true, means we are inferring the schema. This is doing our infer schema part, and then we will be loading the file from path, that is from this particular volume. That's it. This is the whole code all about. And then I will just click on this run pipeline. So now it should do what? It should create a customers underscore CDC underscore bronze table inside my default schema, right? So we can see that customers underscore CDC underscore bronze table has been created at 5:59 p.m. like just now, right? If I come here, so pipeline is still into running phase. So now it has ran successfully, right? And you can see here, you can clearly see customer workspace dot default customer score CDC underscore bronze table has been created. If I want to look at the table, I can directly look at the table from here only, right? So this address, email, first name, last name, ID, append. Here we have also got a new table as rescued underscore data, right? And this rescued underscore data table column we will be utilizing moving forward. Okay. So here you can see, right, all the data from this table. If you want to see the columns, you can see the columns right here. If you want to see the table metrics, you can see all the matrices here. If you want to see the performance, you can see the performance here. Okay. And what I wanted to show you is we have talked about the refresh and the full refresh part of it, right? So here you can see that if I do a simple refresh, it will just run the code and update the data set. And if we will do a full refresh, it will recompute the table from scratch. Okay, means it will recompute all the data from the scratch. That is what full refresh is. Now, if I want to see the performance and everything, we can just click on this, right? And each and everything will be visible to us, that it did a scan, it collected metrics and column to rows. It has written 1 lakh rows into the table, and the table byte was 4.12 MB. And all the information that you want to see, it will be available right here. Okay. If you want to see the execution one, you can also see execution one here, right? And all the things about the tables or about the performance. Here, if you want to see, so you can see the DAG or the pipeline of this particular, I would say the DAG of this particular pipeline, right? So currently we have done only one operation. So we can see only one card right here. When we will do the rest of the operation, so this graph will begin to grow. Okay. So here, if you want to add any comments, version history and all those things are available right here. If you want to check, you want to check it. Cool. So our like ingesting the data to the bronze level layer is basically done. Okay, so click on run file or run pipeline to start an update for the connected pipeline with only one source file in your pipeline. These are functionally equivalent. Okay. When the update completes, the editor is updated with the information about your pipeline. Okay. The pipeline graph DAG on the sidebar is the in the sidebar to the right of your code shows the single table, that is a customer CDC bronze, that I have already shown you, right? This particular DAG which is showing to us. Then a summary of the update is shown at the top of the pipeline asset browser, right? Summary is shown here, right? And details of the table that was generated is shown at the bottom pane, and you can browse the data about the table by selecting it. Okay, so you can see here that we have already seen this thing also, right? Now cleanup and expectation to track data quality. So after the bronze layer is defined, create the silver layer by adding expectations to data to control data quality. Check the following conditions: that ID must not be null, the CDC operation typed must be valid, and JSON must read correctly by autoloader. Okay, so these will be the data quality checks we will be doing like for transforming the data from my bronze layer to silver layer. Okay, so you can see manage data quality pipeline expectation for more information. So you can visit here if you want to see how exactly the data pipeline checks, what all things we usually do. Okay, so let's move forward. Then what we will be doing from pipeline assets, browse the sidebar, click on add and transformation. Okay, so from here we'll click on add, click on transformations. Now enter a name and choose language as this. You can mix and match the language with a pipeline, so you can choose either of in this particular step. Okay, so we can choose either. We can use SQL, we can use Python. So but we will go ahead with the single language, that will be Python. Okay, so here what we are doing the cleanup. So we can write as, let's suppose, silver layer step. Okay, so just let's say only silver layer, and I can click on create. Okay, so silver layer.py file has been created. To create a silver layer with a cleaned table and impose constraints, copy and paste the following code to the new file created, right? So I will do what? I will just copy this code. I will go to my pipeline, and I will paste the code. So I don't think anything needs to be changed here, right? So let's understand the code. So we have done the required imports from pipeline. From PySpark.pipeline, we have imported our DP. From functions, we have imported everything. Then dp.create streaming table. We will create another table as customers CDC underscore clean. Okay. Now we will expect all or drop. Okay. So we will expect what? So no rescued data. Okay. We will create a new column as no rescued data. And if you will come back here, not here. Okay, it was in the pipeline itself, right? If I go here, right, and if I click on tables, customer underscore CDC, so here you will see there is a column as underscore rescued underscore data, right? So this is what we are utilizing here, that no rescued data, we will create a column as no rescued data, and it will only add the data where no rescued, rescued underscore data is null. Okay, where this data is null, it will add all the columns. So right now I guess all the columns will have null values, so it will add these columns, right? Then valid ID, so ID is not null, right? This column should be null and this ID column should be not null, and the valid operations should be operations in append, delete and update. So here if you see any column with having this null operation, it will drop it. Okay, it will drop that particular row. This wiki first name wiki will be wiki return will be dropped from this particular bronze table, and it will not get inserted into this clean table. Okay, then dp.append flow, the target table will be customer CDC clean. Okay, the flow name is this, and it will do what? It will create a stream table with columns as address, email, ID, first name, last name, operation date and rescued underscore data. Okay, so these will be the columns that will get added to my customers underscore CDC underscore clean table, right? And now let's run the pipeline. Okay, so now the pipeline has ran successfully, and now you can see a new table has been created as customers CDC underscore clean. And now if I click on this and if I open it, so you can see address column, email column, ID column, first name, last name, operation date and rescued underscore data. And now in operation column, you will not see any null value. If you scroll it, okay, if I scroll this table, you will not see the null value now, right? So the data has been now cleaned. Correct? I've scrolled almost 1000 rows and we did not see any null value, right? So whatever things we did here, right, it has dropped all the columns where rescued underscore data was not null. Okay, if valid underscore ID is if valid underscore ID column was having null value, it has dropped it. And valid operations, if anything apart from append, update or delete was present, it has dropped that particular row. Okay, and the clean rows or the required rows, it has added to customers underscore CDC underscore clean table. Okay, so because there are now two source files, these are not the same thing, but in this case the output is the same. Okay, run pipeline runs your entire pipeline including the code from step 3. If your input data was being updated, this would pull any change from the source into the bronze layer. This does not run the code from the data startup because that is in the exploration folder, not part of the source of your file, of your pipeline. Okay, so what is the difference between run pipeline and run file is, okay, so if I click on this run pipeline, it will run all the code that is present in my pipeline. It will not only run this exploration folder. Okay, if it will not run this setup data file because it is present in the exploration folder. It does not run the exploration folder. If we have transformation folder or utility folder, it will run that particular file, basically all the files. So it first of all ran my transformation.py file, and then it ran this silver layer.py file. Okay, and run file runs only the current source file. In this case, without your input data being updated, it generates the silver data from the cached bronze table. It would be useful to run just the file for faster iteration when creating or editing your pipeline code. Okay, so if you are creating or editing something in the code, right, so we can only run the file, right? If we don't want to run basically the whole pipeline, we can also run the single file just to check that, okay, whatever changes we made are correct and are successfully running, and it does not have any kind of issue. Okay, now when the update completes, you can see that the pipeline graph now shows two tables with the silver layer depending on the bronze layer. The bottom panel shows details of both the tables. The top of the pipeline shows asset browsers, now shows multiple runtimes and all those stuffs, right? So now if I come back here to my DAG, so in this DAG you will see now, instead of this, let me show you. If I go here and if I click on this view monitoring page, so here you will be able to see the same thing in a much more bigger screen, right? So you can see now the first streaming table that we had created was customers CDC bronze, and after that we have created this customers CDC clean table. Output record, it should show, it's not showing. Okay, you can see also right here that the dropped output record was 96k and it has dropped 3.6k records from this customer CDC bronze table. Okay, so whatever records did not match this particular expectation, it dropped all the records. Now next, create the final gold layer of version of customer table. So materialize the customer table with an auto CDC flow. Okay, so up to this point the table have just passed the CDC data along in each step. Now create the customer table to contain both the most up-to-date view and to be a replica of the original table, not the list of CDC operations that created it. Okay, so this is a non-trivial to implement manually. You must consider things like data deduplication to keep the most recent now. So however, Lakeflow declarative pipeline solves these challenges using the auto CDC operation. So from pipeline asset browser, click on add, click on transformation, enter the name, choose language and all those things. Then to process auto CDC CDC data using auto CDC Lakeflow declarative pipeline, copy and paste the following code in the new file. So I will come back here, I will click on add, click on transformation, and I will name the file, let's suppose as auto_cdc.py. Okay, not .py, I will only write the file name, and I will click on create. Now I will go to the documentation, I will just copy this code, come back here, and I will paste it, right? Now what it will do, we are doing our necessary import. Again, create a streaming table with the name customers. We have given the comment to the table. Now what we are doing is we are creating an auto CDC flow. So dp.create auto CDC flow. Our target table will be customers, that is this table. Our source table will be customers CDC underscore clean, right? That is this table that we have created in the silver layer. Then keys is ID, right? Sequence by column of operation date, like the operation date column. Ignore null values update, false. Apply as deletes. So if operation is equals to delete, you can delete or you can drop that row, right? Expect column list. So what all columns we will not be appending to the customer table will be operation date and rescued underscore data. So the only columns that we will be having will be address, email, ID, first name, last name. Okay, we will drop these three columns, right? Because this right now we are now transforming the data from silver layer to gold layer, right? So it should only have the information that is necessary for the business requirement. Okay, now let me run the pipeline. Okay, so now my pipeline has been completed. Now if I come back here and if I refresh this page again, okay, fine. It's because I have used this one. I have to now use this particular one. So for every pipeline, it will create a new one. So now you can see, right, that it has created customers table, and now it has dropped like only inserted 84K records, right? Deleted 0 and dropped 0. Okay. But earlier, I guess we were having 96,000 records, right? We were having 96,000 records. So wherever delete operation was there, it has deleted all those records, right? And we are aware about the fact that around 10,000, 10% of them was a delete. So around 86K has now been appended to the customers table, right? And if I click on this customers table, you can see the schema, right? We are only having address, email, ID, first name and last name, right? If you want to see the flows, you can also see flows here, right? Total number of records 86,247, 247, right? And now if you want to see the whole data of customers, so you can just click here and you can open the data. So now the data that we are having is address, email, ID, first name and last name, right? So this is the gold layer data now that we are having, right? You can get each and every detail right here also. If you want to check the DAG, so the same DAG will be available here. If you can maximize views, so you can also maximize view right here also. Okay, let me close this and let me come back to the documentation. Now track update history with slowly changing dimension type 2. Okay, now we will use SCD type 2 to track the changes. Okay, so it's often required to create a table tracking all changes resulting from append, update and delete. So history, you want to keep the history of all the changes of your table, and it also gives us the ability of the traceability, that you want to see which operations occurred. So SCD2 with Lakeflow SDP. So Delta supports change data flow, CDF, and table change can query table modifications in SQL and Python. However, CDF's main use case is to capture changes in pipeline, not create a full view of the table changes from the beginning. Okay. Things get especially complex to implement if you have out of order events. You must have sequence of changes by a timestamp and receive a modification that happens in the past. You must append new entry in your SCD table and update the previous entries. Now Lakeflow SDP removes this complexity and lets you create a separate table that contains all modifications from the beginning of the time. This table can then be used at scale with specific positions or Z order columns for Z order columns if required. Out of order fields are handled out of the box based on the sequence by column. So to create an SCD type 2 table, use the option stored as SCD type 2 in SQL or stored as type equals to 2 in Python. Okay, note you can also limit which columns to feature tracks in the option track history on column list or expect this particular column list. Okay. Now from pipeline, we can add a transformation, name the file name and paste the following code. So we will do the same thing here again. I'll click on add transformation. Let's say I'm naming the file as scd underscore type 2 and I click on create. Then I will go back to the documentation again. I will copy the code, come back here and I will paste it here. Now what we have done is again done the imports, the required imports, then dp dot create streaming table. So now we have created a table named as customers underscore history. Everything remains exactly the same that we did in auto CDC part, right? Each and everything remains same, right? The only thing that has changed is this particular thing, that we have given another parameter right now is as stored as CDC type 2. Here by default it has stored it as CDC type 1. Okay. So now all the things are same. Target column, target table is customers underscore history. Source column is this. Source column, not column. Source table is customers underscore CDC underscore clean. Key is ID. We have to sequence by operation date. Then ignore null updates is false. Apply as deletes. So expression wherever operation will be equals to delete, it will delete. And we have to remove the columns as like what all columns do we have to remove or maybe not include in the target table is operations, operation date and rescued underscore data. Okay. And now I will just run the pipeline again. It will take another, right? So it has run successfully. Now you can see customers underscore history table it should give. So customers underscore history table has been created, and now if I look at the table, you can see that we have few more columns, that is started at and ended at. Means these are the columns that were changed or they were basically some kind of transformation was done on these particular columns, not columns, these particular rows, right? So here we are having the both of the versions of the rows, be it the version 1 or be it the version 2. So wherever ended at is null, there is no change, and if there is something as the data that we are having, it means that particular column was of update type. Okay. Um, Maybe if I remove this, okay, if I remove this and if I run the pipeline again, okay, and now if I check, so operation, okay, everywhere it's null. Okay, cool. So for that reason, it was deleting the operation. Let me run the pipeline again, so that we have the required table that we wanted. Okay. Now we will do what? We will create a materialized view. So this is the last step of my pipeline. So here you can see the ultimate thing was to create a materialized view from customers underscore history table as customers history underscore aggregated. Right. So now we will be creating the materialized view. So the table, okay, create a materialized view that tracks who has changed the information the most. Okay. So it will track that which user has changed the information the most number of times. So the table customer underscore history contains all historical changes a user has made to their information. Create a simple materialized view in the gold layer that keeps track of who has changed their information the most. This could be used for fraud detection analysis and user recommendation for in the real world scenario. Additionally, apply changes with SCD2 has already removed the duplicates, so you can run directly the count as per row ID. Okay. So we will be creating a materialized view where it will reflect the count of changes it has made to the data. Okay, the user have made to the data. So let's suppose if a user is changing its username multiple times, like in a more frequent way, so it may be that it is running some kind of fraud or a fake account, right, or something like that. Based on the business requirement or the analysis that we want to do, we can do it. Okay. So now what I will do, so I will just click on a transformation, click this and all these things, right? So I will click on this, I will click on transformation. So let's say materialized view. So materialized underscore view, and I will click on create, and I will simply paste the code. That's it. So you can now see the table that we will be having is customer underscore history underscore aggregated, right? You can see right here. And the table that spark.read.table customer underscore history, we will group by ID, and we will do a aggregation of address, email, first name and last name. So we will get the count of for all these columns every user has changed for how many times, and then we will click on run pipeline. It will start running my pipeline again. Okay, so my pipeline has run successfully. No, still it's in running phase. Cool. Now it has ran successfully. Now if I come back here and if I go to customer history aggregated, and if I open this, now you can see how many times the user has changed the address, his email, his first name or last name, right? So you can see the aggregation of the change of count. Okay, I think there is no two times that has any of the user has changed. Okay, cool. So you can see the aggregation of the number of times the user has changed their address, their email, first name and last name. Okay. So now let's come back here again. Okay. And let me now check the monitoring page. Let me remove this, remove this. We can also remove this, not required. So you can now see this whole graph is somewhat equivalent to the pipeline that we were having right here, right? This is the graph that we were having. That from customer CDC bronze, we ingested the data. I won't say ingested the data. We transformed the data to CDC clean. Then we created a streaming table as customers. And then using SCD type 2, we created a table as customers underscore history. And on top of this customers underscore history streaming table, we have created a materialized view, right? And whatever we want to do, whatever we want to check, we can check all the details right here for everything. Okay, we can check every detail here. Okay, why it's not showing? Okay, fine, cool. So this is it. And now what all things is rest. Now we will create a job of this particular ETL pipeline. Okay. So now if I come back here and if I open my jobs and pipelines thing, so you will see currently this pipeline with CDC tutorial. You can see currently it's a pipeline, right? We have created an ETL pipeline. But as soon as I will orchestrate, I will schedule this particular pipeline, it will, the type of this pipeline will change to a job. Like it will not change this type only, this will remain and it will also create a new job from the pipeline. Okay. So how we can do it? Let's understand. So at the top of the editor, choose schedule button. If schedule dialog appears, add schedule, open new schedule dialog and optionally give the name and all those stuffs, right? So I will do what? I will come back here. I will click on this schedule button, right? And I can click on this add schedule. Okay. So already the job name is given. So then I will go to advance every day at 3. So it's 3:33 right now. Maybe I can run it on 3:35. Okay. And the timeline will be plus 350 Chennai, Kolkata, Mumbai, right? And I will click on create. So you can see job has been created successfully. Okay, now if I come back here, so you can see a new job has been created. So as soon as I orchestrated this particular pipeline, means I scheduled this pipeline, the pipeline got converted to a job. So this is the only difference between a job and a pipeline. That the pipeline when orchestrated, when scheduled, becomes a job. Okay. So now we will have to wait till 3:35 at, sorry, 6:35. At 6:35 it should run. So we will have to wait for a minute. Okay. Now, so what we will do? We click on create, apply. Now the job will run daily to keep on track and all those things. Okay. Keep the name. Okay. Fine. Okay. So let's be here. Within next few seconds it should run. Let's see if it runs or not. Okay. So it's 6:35. Now it should run. So it's taking some time to create the underlying compute. So we have already learnt about this part, that the job will create its own compute, and then it will run on that particular compute only, right? So I hope everything is fine. Let's wait for a few more seconds. It should run. Cool. So now you can see it has started to run. So it took some time to create the compute to run the job. Okay. So it has started to run. Now what we can do is we can just click on this particular thing and we can see the status of our pipeline, or I would say not our pipeline, of our job. Okay, so it's taking some time. Actually, it's running everything, right? So it will take a bit long time. Okay. So after running for 2 minutes and 3 seconds, the job that we have created has successfully ran. Okay. Now we can get all the informations about the job and everything, right? The same DAG and all the stuffs: run ID, job ID, task, who ran it, when, by whom it was launched, when started, when it ended, what was the duration, success, lineage, and all those things. All the information that you need basically will be right here. Cool. So this was pretty much it, right? So in the previous video already we have talked about the Spark Lakeflow Spark declarative pipeline components. There we had understood all the concepts about what exactly is an ETL pipeline, what is CDC, what is Lakeflow SDP, right? What is a streaming table, what is a materialized views, and all these concepts we have learned theoretically, right? Now in this video we have done each and everything practically, right? So I hope now even things are getting more clear, right? Moving forward, when we will be doing a few more things, right, concept will automatically, like the component the concepts, the components, flows, and each and everything will become even more clear to you guys. Cool. So I hope you learned something new in this particular video. I will see you in the next one. Till then, keep learning and keep growing. Bye bye.